All right, hello, and this is Wednesday's lecture for Evaluating Statistical Hypotheses, Part 2. You may notice a different setting, lots of computer drama. I'm on a different computer, but fingers crossed this will all work. So, yeah, continuing from where we were. So, one way, let's look at a particular survey, right? And this will help us sort of like walk through the method for evaluating an actual survey. So, we've sort of built up a lot about understanding, right, statistics and these margins of error and using the margins of error to evaluate whether there are statistically significant correlations and so on, right? So now we're going to apply it all. So if any of that sounds confusing or you don't remember any of it, review the material right from the last lecture. So now we're going to use this stuff that's been presented so far in a fairly abstract way, right? But there's not too many ways around that. Okay, so here's an actual survey that happened. So this is the 1997-1998 Health Behavior in School-Aged Children. We'll call it HBSC for short. Cross-national survey by the World Health Organization. So they looked at a number of different countries and 28 different countries, right? And the idea was just to understand the relations between certain behaviors, health-related behaviors in young people and their health outcomes. So the idea was to identify, right, groups that are at risk of bad health outcomes later in life at an earlier age, see if they can find any sort of correlations between certain behaviors and bad or good outcomes, and develop strategies to intervene at a younger age, school age. They made it cross-national, right? So they surveyed many different countries because they also were hoping that they might be able to find out if there were any sort of trends they noticed that were universal across all countries, or whether there were other things that were actually sort of culture specific, right, to a particular country. That's all stuff that you might be interested in knowing. So the survey was administered to 3 age groups: 11-year-olds, 13-year-olds, 15-year-olds, right? Fairly specific. And they used the exact same sampling technique in each country. It was a very specific sampling technique we'll see is called cluster sampling, right? So the surveys happened in schools, right? And they would do it by classroom, right? Now, in school-aged children, right, some 13-year-olds will be in 7th grade, some 13-year-olds will be in 8th grade, right, depending on how early, right, what age they started school, what their birthdays are, and so on. So that being the case, the sample would be split for 13-year-olds between 7th and 8th grade, right? So, for example, if 80% of the 13-year-olds in the United States are in 7th grade, then 80% of the surveys in the United States that were aimed at 13-year-olds were given to 7th graders, right? So you might end up, right, that some non-13-year-olds are taking your survey, but they're going to be close, right? So the average age was 13.6, so pretty good. There was a recommended sample size, right? Because of this cluster sampling method, there's a very specific sort of sample size that was required. So it was 1,536 individuals, right, were sampled in each country. And given the method they were using, that would guarantee a 95% confidence level for a sample frequency of 0.5, right? That would, if you look at our chart, that's what it should give you, right? Okay, so they had a total of 123 and some children, right, complete the questionnaire. Close to half and half boys and girls, about 49%, 51%. And then as well, they came pretty close to splitting it fairly evenly between 11, 13, and 15-year-olds, right? 32%, 34, 32%. So the classes, right, that were sampled, so they pick a class and everybody in that class would get a survey, right? They were chosen randomly from all the schools in the country. They really tried to make sure that, like, for example, they had to use different translations, right, of different surveys. They were in different countries, but they tried to make sure that they were all equivalent, right? Again, they tried to choose randomly from all the various schools. Okay, so they in the survey, they asked, again, about various health-related factors, right? Say smoking habits, physical activity, right? Do you play sports, so on. And then subjective health assessments, right? So how healthy do you think you are, right? Might be, you might prefer objective assessments, but when you're dealing with a survey, right, you kind of have to use self-report a lot of the time, right? So there's a whole, we won't go through all the results. It would make this lecture far too long, right? But they're in the text, pages 162 to 167, so you can kind of, I encourage you to sort of like look at them and kind of make sure that the chart makes sense to you and that you can see how much data they had, right? A lot of data. So we're just going to focus in on a couple of specific results, right, that they found as an example to apply our program for evaluating statistical hypotheses. Okay, so what is our program, right? So first we need to figure out what the real world population is, right? This is step one. Well, every statistical study is trying to find something out about a specific real world population. So what is that population? For this survey, the population of interest was young people, right, aged 11 to 15 in all of the, what did they say, 28 countries, right, that they surveyed. I think they were largely in Europe and America and stuff, maybe less so in like sub-Saharan Africa. And that's relevant, right? So, so strictly speaking, right, there's always this issue that we're only getting information from the sample, right? And there's always a chance that the sample could differ from the actual population of interest, right? So the actual population of interest is all children in that age group, at least maybe in those countries. We only sampled 100,000 of them. That's a lot, but it's not, there's far more children in those countries, right? So we can't just assume that everything that we know about the sample can be extended to the real world population, right? So we have to be very careful about ways that our sample might differ from the real world population. To take one example, right? If you're a child in France, right, you were given the French survey. If you're in school but you don't speak French well enough to take the survey, then you're not going to show up in their data, right? You're not going to be sampled. You can't do the survey. So that might be relevant. You might want to know something about, right, school children that don't speak the language, right, of the country well enough to take the survey. They're going to be left out of the sample, even though they're a part of the population. Or say homeschooled children, right? They're not going to be in the classrooms. They're not going to be taking the samples. So there might be interesting facts about homeschooled children, right? They might differ interestingly from the people who are sampled. Homeschooled children are part of the overall population we're trying to learn about, and they're not in the sample. So there's always going to be some differences there. And as long as you the best thing to do is take note of them and try to make sure that it's not going to sort of distort your results too badly, right? So, I mean, one thing you can say is like, okay, whatever conclusions we draw here, they're not going to extend to children who don't speak the language or children who don't go to school, right? All right, here's the attendance quiz. Giving you a little time to type it out, if that's what you do. And all right, well, you can also just pause it if you need to. All right. Okay, so nice thing about survey studies, you can get a whole lot of data, right? And I skipped over a lot of it because it's too much, right? And you'll kind of want to do that in your analysis too. You're not going to want to cover all of the data, right? So feel free to just focus in on something very specific, right? So let's focus in on one bit of data. 92% of all the young people surveyed, right, reported considering themselves healthy, right? So the actual options on the survey were very healthy, quite healthy, not very healthy. So the first two, very healthy and quite healthy, those were both lumped into one bucket, the healthy bucket, right? So that's 92% of the children answered one of those two. And then we can infer, right, since those answers are exhaustive and exclusive. The other 8% consider themselves unhealthy. All right, so that's the real world and a little bit about the sample taken from the real world. So the other part of our analysis is we need a statistical model, right? So what statistical model should we use? Well, one way, the way to get started on that is just to look at the data and then sort of work backwards. So what are the variables? What are the values of those variables, right? Start filling in those blanks and you're constructing your model, right? So here we're talking about a simple proportion, right? It's 92% consider themselves healthy versus the 8% that consider themselves unhealthy. So that's one variable, right? Health status, it's got two values, healthy and unhealthy. A distribution would have a variable with 3 or more values, right? For example, with marbles, red, yellow, green, right? That would require a distribution. So what we're looking at here is health, one variable, two values, healthy, unhealthy. So that's going to be a proportion. All right, in evaluating our studies, we're going to need to look at how close the sampling is to random, right? So everything we've learned so far assumes a random sampling model, right? If the actual sampling does not approximate random sampling, we can't be sure that the model, right, is appropriate. So we need to look at the sampling method and try to see if it's actually random, right? So what does it mean for a sample to be random? Well, remember back in chapter 5, that means that, number 1, all members of the population who might exhibit the property of interest have an equal chance of being selected, right? So there's no bias towards selecting any particular individuals. And then 2, there's no correlation between the outcome of one selection and any other, right? So selecting one red marble doesn't increase or decrease my chances of selecting another red marble. This HSBC survey actually does violate both of those conditions, right? Lots of the time, real life surveys will. So, for example, by using the cluster sampling, right, where they pick classrooms, that means that not all members of the population are going to have an equal chance of being selected. If you don't speak the language, right, or you are not in school because you're homeschooled, you're not going to be selected, right? You have 0 chance of being selected. So that violates condition 1. And condition 2 is also violated, right, because classrooms often select students based on certain behavioral or scholastic variables, right? So you might have all the honors students in one classroom, right? Or you might have remedial classes. So that's going to mean that it's possible, right, that some of the responses that you get on these surveys will be correlated with each other, right? If children who are unhealthy, for example, miss a lot of school, have to be in the remedial class, you may be finding more children responding unhealthy, right, in that classroom. So there's a correlation there. So nonetheless, right, despite the fact that it does violate sort of both conditions on random sampling, this technique has been shown sort of rigorously, and they're just asking you to trust them here, that if you have a large enough sample, it will approximate random sampling, right? And that's the reason for the pretty large sample size. So even though it might not seem random, they know that if you get a big enough sample, it'll act like a random sample. Okay, next we will evaluate the hypothesis, and I'll give you the step 1, step. So these are all the steps. We're going through them, and then I'll summarize them for you, right? So the next step will be evaluating the hypothesis. So big sample size, right? So 120,000. So margin of error when you're looking at the whole population, right? Healthy versus unhealthy. That's the proportion we're looking at now. You got a small margin of error, less than 1%, right? And because, right, the relative frequency is very different, right? 92%, right? So that means that the proportion of 11, 13, and 15-year-olds in those 28 countries who report themselves to be healthy is 92% plus or minus a 1%, right, margin of error, so somewhere between 91 and 93%. And those that reported themselves unhealthy, right, it was 8%, so that means between 7 and 9%, right, in the population would probably report themselves to be unhealthy. So that's pretty good evidence, right, that we've got more than 9 in 10 of the young people in the population would report themselves to be healthy. And in the last stage, and this is sort of well, these are all kind of new, pretty different than what you saw in sort of the early chapters for evaluating those scientific episodes. This one in particular is a new one. There's a little summary stage at the very end, right, where you sort of like summarize the important bullet points from your earlier analysis. So it's important in the summary section to cover at least these 2 points, right? So first, again, the random sampling, right? You can only really make some sort of rough qualitative judgments about this, but how random is the sample? So in our summary, we noted that in this HBSC sample, there's some problems with the cluster sampling, right? Small percentage of students are going to be left out, right? Don't speak the language, homeschooled, etc. There might be correlations among students in the same classes, right? Honors courses, remedial courses. But the study does acknowledge this, specifically, right, uses a large sample because it's known to sort of compensate for that problem. So in general, we can say they did a pretty good job of random sampling, right? And then you want to ask yourself, okay, what's the actual conclusion we should draw? So in this case, we can be confident, right? The margin of error is very small, between 91 and 93%, right? That interval does contain the actual value of the proportion of school attending children ages 11, 13, and 15 who would consider themselves healthy, right? Both in the sample and in the population of interest, right? So fairly specific conclusion, right? But that's all they show, right? That doesn't tell us necessarily anything about 10-year-olds or 17-year-olds and so on. All right, and here is the chart, a figure from the text, right? So again, in evaluating these models, it can help you to actually just sketch it out, right? Put a box when you're looking at the real world population. Make a box for that one, right? Even make a little box inside it that represents the sample, and then you can reproduce that little sample box down there. Draw your relative frequency, right, which is 92% healthy. You've got your sample size down there. Then you look it up on your chart. You got your margin of error plus or minus 1%, and now you've got your arrow back, right? So you can say, okay, from this sample where we have a relative frequency of 92%, right, we can estimate backwards that the proportion in the population that would consider themselves healthy is 92% plus or minus 1%. So you may find, again, this can be part of your evaluation. It may help you to sort of like work through it. Okay, so now let's sort of walk through the stages again in sort of more abstract terms, right? So if you need to evaluate a statistical hypothesis, right, the steps are, again, repetitive, but I think important, right, helpful. It's sort of a new thing. You've been using kind of the same program for a while, and now there's some significant differences in this one, right? So step one is still sort of the real world, but here's the real world population, right? So what is the population, right, that we're interested in? What is the population that we took the sample from? And in this stage, note any important differences, right, that you might notice between the population sampled and the population of interest, right? In this one, we noted, well, some people are going to be left out, you know, if they're homeschooled, and so on, right? Okay, step two, the sample data. So right away, just now look at the data, right, and tell us what. And again, you know, if they give you a lot, right, you don't have to evaluate all of it, but pick some particular data and evaluate it. Sometimes it'll be very clear sort of which one you're supposed to evaluate, right? and just right, tell us what they tell us, right? The relative frequencies that they find in the sample for different variables, the sample sizes, stuff like that, right? Okay, so you get your data sort of out there like pretty early in step 2. Then you go to the statistical model. In the statistical model, you just all you really need to do is identify the relevant variables and the values of those variables, right? And then sort of like identify the statistical model that's appropriate for evaluation in light of the data already identified, right? So if we're dealing with a correlation, right? Are we just dealing with proportion, like we were in the last one? Are we dealing with a distribution? And in that case, sort of give a clear statement in step 3. Give a clear statement of what the statistical hypothesis is, right? Is it right, claiming that there's some correlation in the real world population, right? Is it just saying something about the proportion of a particular value of a variable in the population, right? What's being claimed? Okay, step 4. Here we assess whether the sample was random or not. There might be some overlap between step 1 and step 4, right? So things that make the sample not random may also be things that make the sample differ from the real world population, right? But it's fine. If it needs to be said twice, say it twice, right? So how well, right, does a random sampling model represent the actual process? And you have sort of various possible answers, A, very well, moderately well, somewhat well, or not very well, and explain why, right? Was one of these conditions violated? The 2 conditions on randomness, random sampling, right? Okay, and then step 5, right? Let's evaluate the hypothesis. Let's assuming, right, that the random sampling model is applicable. If it's not, then it's kind of like all bets are off because that's the only model we have. But let's assume that it is. What can you conclude about the real world population, right? Which was, and again, the hypothesis was stated in step 3, right, when we talked about the model. So say the hypothesis was that there's some correlation in the population, right? Talk about whether there's good evidence for that. So this will involve doing the math, right? And so you take the relative frequencies, you find the margins of error, right? You draw it out if you like and see if there's overlap, right? If there is overlap, then that's evidence there's not a correlation, right? If there's no overlap, then that's evidence for a correlation. You go through that whole process that we talked about in the last lecture. So step 5 is kind of where you do all the work and actually sort of like figure out the numbers, figure out if it's true or not, or if there's good evidence or not for the hypothesis. And then finally, step 6, again, is just the summary, right? How well does the statistical data support your evaluation? And again, we pointed out sort of the important things that you may want to point out in that stage. So those are the 6 steps, right? That's the program here. So as I said before, I think drawing out the diagrams will be very helpful as you're going through this process, right? Each stage, right, you can kind of add a box and it'll help you sort of focus your answer and make sure you're covering everything you need to cover, right? So step 1, we're talking about the real world population, right? Draw your box, right? And the smaller box inside with the population sampled. And if you need to take any notes about sort of differences you've noted or anything like that, you can jot it down there. So that's sort of step 1 and step 2, right? And in there, right, go ahead and jot down any of the relative frequencies, sample sizes, right, things like that. Then in step 3, sort of you can add any more detail, right, that you need. And step 5, you're going to want to be charting out the appropriate intervals, right, representing estimates of margins of error and things like that. So yeah, feel free to like, it's getting to where you really kind of need to think with your hands on the paper, right? And just use the pencil to sort of like, to get it all out there, and it will help it make sense to you in your head. Okay, let's try this whole process one more time for good measure. We sort of like, I don't know, this is the way the book does it, so I just did it the way they do it, but they kind of present an example of the the evaluation without giving you the stages of the evaluation first, so you kind of didn't know what you were doing yet. Then they gave you the 6 stages of evaluation in sort of the abstract, right? So now hopefully it's all coming together. You've seen one example, you've seen the 6 stages spelled out. So now let's put it all together with one more example, right? So the survey also reports 61% of American youth, and this is all genders, all age groups, right, reported not bullying any other schoolmates during the previous term. Whereas 85% of Swedish youth reported not bullying. Why they frame this in terms of not bullying as compared to bullying, if I looked at the data, maybe it's because like bullying is split up into different things or something. But anyway, this is how they frame it. It's fine. That's a perfectly good way of framing it, right? So, how many American youth don't bully, and how many Swedish youth don't bully? So, what's the real world population here? Well, it's the same as the previous time, right? It's just all these school-age children, right, ages 11, 13, and 15 in these 28 countries. And you can add sort of all the details, right? Well, the ones who were capable of completing the survey, right, whose classes were chosen randomly. So you can say here that there probably should be little difference, not too much difference between the population actually sampled and the population of all school-attending children, right? If you want to put in more detail about the folks who might be left out, or you can put that in the random sampling section as well. Some of this stuff is a little repetitive. You won't get marked down for being repetitive, if you want to do that. But it's up to you if you want to, some of this stuff, if you want to put it in step 1 or if you want to put it in the random sampling step. Okay. Step 2. Okay, so what was the data? Well, among the young people surveyed, 61% of the Americans reported not bullying schoolmates during the previous term. 85% of the Swedish youth reported not bullying schoolmates, right? And we had a total of, sample sizes are important here, right? So we had about 5,000 Americans and about 3,800 Swedish completing the survey. So that's, again, going to matter for our margins of error later, right? Okay, so what's the statistical model here? What are the variables? What are the values of those variables? Well, here we've got 2 variables, right? We have got the nationality, right? The 2 values being American and Swedish. And we've got another variable, which is self-reported bullying, right? Values being none, right? No bullying at all, or 1 or more times of bullying in the last term. And the data, right, once you work it out, there will be a correlation, right, a weak correlation between being Swedish and reporting no bullying. Again, in step 5, we'll do the math here. Okay, so does this model approximate random sampling? We've sort of been through this in some detail. You can repeat it largely from the previous example. You can talk about the cluster sampling technique and how it has these potential problems, right? These failures of randomness on both criteria, but the compensation for that in sample size. Right? I won't go through all that again. I feel it's been covered. Okay, so now step 5, evaluating the hypothesis. So where do we find this weak correlation? How do we decide this, right? Well, the rule of thumb margins of error for a sample of 5,000 and 3,800 is 2% each, right? Close enough. So that means that the observed difference is statistically significant if you look at, right, and here we're doing the quick rule of thumb. The margins of error sum to 0.04, right? The difference in the observed frequencies is 0.85, right, in Sweden, 0.61 in the US, so that's 0.24, right? So that's definitely bigger than 0.04. So evidence of a correlation, right? Now that if you are not comfortable with the quick rule of thumb and instead you want to chart it out, right, and put on one side, okay, we got, right, 0.85 plus, and so the interval, right, is what, 0.89 to 0.81 or something like that. Feel free to do it the long way too. Either way is fine. Okay, so we've got the evidence of correlation, and then we can calculate the estimated strength, right? So that's going to be 0.85 minus 0.02 plus 0.61 plus 0.02, right? So that comes to 0.2. So it's a correlation, relatively weak one, right? And again, if that felt like it went too fast for you, that's all in the last lecture, right? But so go ahead and review that, right? If you can't remember or why this, again, this is the quicker rule of thumb way, right? For evaluating the strength of a correlation. You can also do it the slower way with the chart, if that makes more sense to you. Okay, and then step 6, the summary. So given that the HBSC does really fit a random sample model pretty well, right? Given the caveats we've already discussed, and given the difference between the observed and sample frequencies, what I mean is between the observed sample frequencies, sorry. Yeah, the difference between 0.85 and 0.61, right? Given the relatively small margins of error, we can be confident that the population sampled exhibits a statistically significant positive correlation between being a Swedish school child and not bullying schoolmates as compared to being a school-attending American child and not bullying schoolmates. And we can say that there's good evidence that the same judgment applies to the population of interest. Right? So here is, right, the chart, if you were to draw it out. So you got US on the left, Sweden on the right. Then down here, that's on the top is the real world population. Down at the bottom, we've got our sample. We find 61% in the US reporting no bullying, 85% in Sweden. We figured out of our margins of error is about 0.02 in each case. So you bring it back up, estimation back up to the population of interest, and we've got our intervals up there. They do not overlap, right? So it looks like we have got a correlation and then a little quick math and subtraction, and you can get the strength of the correlation. Okay, getting towards the end here, coming up a little shorter lecture than usual. Hopefully that's good for you. So a couple problems you can run into with survey sampling to look out for. So you can run into, it's very easy, right, to fail the criteria of random sampling, right? Now the first criterion, right, is to ensure that every individual in the population has the same chance of being chosen, right? How do you do that? A popular way back when phone books existed and everyone was in it and everyone picked up their phone because they didn't have answering machines or screen their calls, like the 80s or something, the 70s. Yeah, you could pretty much get a random sample by just sort of randomly picking names out of a phone book and calling them. Now, of course, you'd still have issues about, like, for example, are you going to get more men or more women, right? Are you going to get more people that don't work, right? Because people at work are not going to answer their phones, and that'll depend on when you call and so on, right? So even, like, I don't know how much more random you can get than just sort of randomly picking a name out of the phone book, but still there's going to be biases that are going to creep in, right? If somebody's not home, they're not going to answer their phone. So an example of sort of like the sorts of problems you can have was Kinsey's study of sexual behavior. So this happened in, I want to say, the 50s. And it was kind of a surprise. There was a movie about it. Like the results were surprising because it seemed like, oh, all these, America seemed pretty uptight at the time, but it revealed that like a much larger percentage of people than you would think like had homosexual experiences and stuff like that, So Kinsey's sampling method was sort of what we call a sample of convenience, in that he just sort of like kind of walked up to people and asked anyone and everyone, right, if they would participate. Well, that means that you're going to get, what's the bias, right, that could creep in there? Well, it's people, certain sorts of personalities. If you walk up to them and say, hey, will you, do you want to fill out the survey about your sex life, right? Certain more outgoing, right, certain more open people are going to fill out that survey. Very sort of timid or uptight or just not, whatever, I don't know what the word is, but the type of person that would not be eager to do that sort of thing is not going to want to do it. And so it's not surprising, right, that you might get results and you might get a sample of people that are on average more sexually adventurous, right? They're just more outgoing and more open about sex and happy to fill out a survey about sex. So that's, it seems very plausible that bias creeped into the survey in that way. Another problem with survey sampling is unreliability of information. So this comes up, right? You may have wondered when they assess these children's health, right, by asking them if they think they are healthy, how many of these kids are going to be honest about that, right? Aren't you just going to want to report, yeah, I'm healthy? People often will tend to sort of lie or bend the truth or try to appear better than they are, even if they know they're dealing with an anonymous sample or anonymous survey, right? Certainly, right, if you ask 11-year-olds, do you smoke? If that's on the survey, they're not going to probably want to say yes to that. I think they'll get in trouble. I suspect that a fair amount of them that didn't engage in bullying didn't respond that they did much bullying, either because they either don't consider it bullying when they do it or they wanted to hide it and so on. So yeah, just asking people to sort of tell you the truth is not super reliable sometimes. You do what you can. You assure them that the results will be confidential. You can even screen them for sort of a personality that seems more or less honest or willing to talk. But there's really no way with a survey to know how honest participants are being. Something like this seemed to be an issue in the exit polls for the 2004 U.S. presidential election, right? So exit polls typically are very reliable because instead of sort of in the run-up to an election, they call people up, who you're going to vote for, but you never really know if that person's going to vote for sure, right? And they ask them, are you a likely voter? Did you vote in the last election? And so on. And if they're being honest, you can kind of determine how likely they are to vote. But if you're standing outside the polls, right, asking people as they walk out, hey, who'd you vote for? Much more accurate. But nonetheless, in 2004, the exit polls showed John Kerry with a huge lead over Bush, right? Bush Jr. But then when the actual results came in, Bush actually won, like very easily, right? So the question is, what the heck happened, right? Well, lots of potential answers to that question were proposed, right? So could it have been the time of day that the polls were conducted was somehow favored, right, Democrats, or maybe there seemed to be more women in the sample than maybe normal, and if women tend to vote Democrat more often, that could be it. They thought maybe Bush voters were reluctant to talk to pollsters. That was certainly thrown out there as an issue with Trump voters, right? That they were somehow, since he was maybe mocked by some people, they wouldn't want to tell the pollster they voted for him, even if they did, or something like that. There were even like conspiracy theories, right, that the polls were deliberately leaked early to discourage Republicans from voting, right, because they're going to think, oh, it's all over, right, stuff like that. But those are just stuff thrown out there. So there was an official report, right, and the conclusion they came to was there were sort of two factors that were pretty important. First, it did seem that Republicans were less motivated to talk to pollsters in general. They don't say why, right, but they did seem to notice that. Again, the pollster stands out there and they say, hey, do you mind taking a survey? And some people say yes, some people say no. It seemed on average Republicans were less likely to say yes. And then that seemed to be exacerbated by the the fact that the pollsters, the people doing the polls standing out there, tended to be younger on average, maybe college students or whatever, and Republicans tend to skew a bit older, right? They might see a younger person, think, oh, that's a Democrat. They're not going to like me if I say Republican. I don't want to get involved in that conversation, right? So that seems just another way, right? That surveys, there's problems, right, with bias and randomness in surveys. Okay, that is it. I hope that made sense. I mean, you may notice that like this program for evaluating hypotheses, it may seem a little fuzzier or something, right? You might say, well, it seems like in step 1, I'm talking kind of about the randomness of the survey, and then I'm also talking about step 5, and then like in step 3, I'm telling you there's a correlation, but I don't actually evaluate it until step 5. It's okay, right? Get all the information in there. Don't think of it as confusing, just think of it as flexible, right? There's, as long as you get the information in there, there's different spots where you can put it. And the more you practice it in the exercises, you'll get used to it. And we're not like, again, on the exam, we're not out to hammer you, right? To like get points off or something. Like if you get the information there and it all makes sense, it'll be fine. So don't worry if on first pass, right, there seemed to be some ambiguity in the evaluation. Again, just think of it as flexibility, lots of ways for you to get that information out there. It'll be fine.